Hey, thanks for tuning in to another edition of Check This Out Mathematics. And we are going to take a little break from doing lessons on logarithms to doing what we're going to call features of logarithms. Okay? The idea is that logarithms are extraordinary. They have extraordinary features. And so these are features of logarithms. And so all of these features of logarithms are going to be based on the change of base. Okay, how do you like that? Okay, so let's remember the change of base property here, or the change of base feature of logarithms. How about that? Okay, so we start out with log base b of x equals n, and then we can make that round trip b to the n equals x. Okay? And then we can take the log base a of both sides. And then we remember that when we have a exponent here, when we have a power, that means we can multiply the powers. So the log base a of b is a power, and n is a power. And so now this becomes a power to a power to a power, which means we can multiply the powers. So n is one of the powers, and the other power is log base a of b. And so that n can come down in front. That's the up top, down in front idea. And then since this is being multiplied, we can divide it to the other side. And then we remember that in the beginning we had n equals log base b of x. And so instead of writing n here, we're going to write log base b of x. And so now here's the change of base property, that if we have log base b of x, that's the same as the log base a of x, as long as we remember that it wasn't base a to begin with, it was base b. Okay? Okay, so that's our change of base. All right, so now the let's do our first feature of logarithms. And this is going to be about when you have products of logarithms, and you have different bases. Okay? Products of logarithms, and there's different bases. So we want to know what can we do when you have log base b of a times log base a of c. Okay, so here we have a product of logarithms. And so what can you do when you have log base b of a multiplied by the log base a of c? That's what we're going to find out here. Okay, so let's let's write our change of base property here. So since log base a of c is the same as log base b of c, as long as we remember that it wasn't base B to begin with, it was base A. Here's just a changing up of the variables, same statement, okay? So the log base A of C is the same as the log base B of C, as long as we remember that it wasn't base B, it was base A to begin with. Okay, so since that's true, the change of base property, then when we have our question here, what can we do when we have log base B of A times log base A of C? Okay, so let's write that down, that we have log base B of A times log base A of C. Okay, so here we have our product of logarithms, and we're wondering what can we do with this statement here. The log base B of A times the log base A of C. Okay, and so let's use our change of base right here. And so instead of writing log base A of C, we're going to write this change of base statement here. So now the log base A of C is the same as the log base B of C over the log base B of A. And we have the log base B of A right there. Okay, so the log base A of C is the same as the log base B of C over the log base B of A. So we have right here. And so then we just brought down the log base B of A here. And now notice, because I changed it from base A to base B, then this is in the denominator and this is in the numerator, and so those divide out. Okay, so we're going to divide those out. Okay. And so now, this is what we have left right here, log base B of C. Log base B of C. Okay, so check this out. That's the name of this channel, right? Check this out, mathematics. Okay, so all right, let's see. So I had started off with the log base B of A times the log base A of C, and I changed the base, and then I just had log base B of C. So let's write this out as one statement here. So the log base B of A times the log base A of C is the same as the log base B of C. Okay, so starting with what we began with here, I rewrote that, and then this was the result of the changing of base. And so look at what this is saying, that if I had the log base B of A times the log base A of C, it's as if this argument, A, cancels out with this base here, and we just have log base B of C. That's what happens. Okay, now let's do an example of that to see that it makes sense. All right. Okay. All right, so check this example out here. I have the log base 2 of 8 times the log base 8 of 64. Okay, and so now the property, the feature of logarithms, this is our feature of logarithms here. Okay, the feature says that we can just cancel out the argument and the base, and then we have log base b of c. And so that's what we're going to do here. We're going to imagine that we can, so to speak, cancel these out like this. And then we have log base 2 of 64. Okay, now let's see that this makes sense. The log base 2 of 8. The log base 2 of 8 is 3, right? Because 2 to the third is 8. And then the log base 8 of 64 is 2. Because 8 times 8 to the second power is 64 there. Okay, so now we have log base 2 of 8 giving us 3, and the log base 8 of 64 giving us 2. Okay. And then this becomes the log base 2 of 64, which is supposed to be 6 by our multiplication there. And so let's see that it is 2 to the 6th power. If we have 2 times 2 times 2, that's 8. And another 2 times 2 times 2, that's 8. And 8 times 6, 8 is 64. So there you go. If you have 2 to the 6th power, 2 times 2 times 2 times 2 times 2 times 2, that's 64. Okay, so it's true. Pretty awesome. Okay. It's not true by example. It's true by proof. True by proof. The example is just an example. Okay. Of truth. Okay. All right. We're going to cut this and do another feature of logarithms. So, hey, give this video a thumbs up and subscribe to the channel, and give me some comments down below. All right, Mr. O'Donnell signing off.